This video covers sections 3.3 and 3.5 from your text. And looking at section 3.3 first, we're going to introduce the concept of the slope of a line and start to talk about how that slope affects the equation of a line. So just first off, let's go ahead and look at an example of a line and talk about what slope is in relation to that line. You see here we have an XY coordinate system, x-axis the horizontal axis, y-axis the vertical axis. And we have this red line, and then we have 2 points here. We have a first point or ordered pair x1, y1, and then a second ordered pair x2, y2. And we want to talk about the fact that if we move from this first point to the second point, there's 2 changes that have to take place. There has to change a vertical change has to take place, and a horizontal change has to take place. And when we're talking about slope, a lot of times in math we give specific names to these changes. We call the vertical change a rise and the horizontal change a run. And so all slope is it's the ratio of those 2 changing quantities. So slope is the ratio of how much you rise over how much you run. More importantly though, this has many applications when we're talking about applications that have constant change. So we also want to think about slope as a rate of change, and especially in regards to applications. For example, you might have something like miles per hour. That's a rise over run. You might have something like miles per gallon. And there's many applications of this, but for now let's just remember that slope can be thought of as a rate of change, and that slope is just a ratio that describes how much you rise to how much you have to run. And so we can find the slope of a graph just looking at its line by looking at how much it rises and runs. So in this particular picture here, we have this black line, and we have 2 points. We have a blue point and we have a red point. And we typically want to move from left to right when we're considering how to find slope. So if I start here at the blue point and I move to the red, or that might be pink, I don't know, we are going to have to go, we'll have to rise -8. Now why do we say -8? Because we're actually not rising. We're not going up, we're going down. So anytime you go down instead of going up as you move left to right, we're going to think of the rise as negative. And in this case, it drops 1, 2, 3, 4, 5, 6, 7, 8 units. So the rise is -8. And then the run, we have to move 1, 2, 3, 4 units. So the run is 4 units. So this is our rise, and this is our run. And of course this does simplify. -8 over 4 is -2. So our slope in this case is -2. And you can always tell that just from looking at a picture. So another important thing that you're going to want to know is that we give a variable to always represent slope, and it is the variable m. So anytime you see m equals something, it's really code for saying that's what the slope is. Now there's this formula that we can use to find a slope of a line that passes through 2 points, and I like to, this is a Strickerism, I like to call this the wise up slope formula, and you'll see why here in a second I like to call it that. So this is m equals, again remember m is what we use to represent slope. So to find the slope m, we find this ratio y2 minus y1 over x2 minus x1. Again, this is just kind of a fancy way of saying rise over run. This is a change in y, which is how much you rise, and this is a change in x, which is how much you run. And you can even see that in the picture here. This vertical change up above was y2 minus y1, and the horizontal change was x2 minus x1. Now, why do I call it the y-up slope formula? Because the y's are up. So, somebody in class, we get to class next time, somebody asks you, how do you find the slope again? If you know the 2 points on a line, you just have to tell them a simple phrase. You just say, y's up. I know that's a bad joke, but it helps people remember. So how do we find the slope of a line if we know 2 points on it? We y's up. So let's see how this works. We have an example here. If I want to find the slope of a line that passes through the points -1, 3, and 4, 4, we know that we y's up. So we go y2 minus y1 over x2 minus x1. And this is where I think it's really nice to label these points. So we could call this x1, and then we could call that y1. And then we, on this second ordered pair, we could call this x2 and y2. And so then you're just plugging into the formula. y2 minus y1 equals 4 minus 3, y2 minus y1, over x2, which is 4 minus x1. This is where you have to be careful with the signs. We're subtracting, and then x1 is a -1, which really means here, of course, that we are taking 4 plus 1. So if I simplify this, 4 minus 3 is 1 on the top, and then the run is 4 plus 1, which is 5. So the slope is 1/5. Okay, now when we have lines, there's sometimes lines that could have positive slope, some lines have negative slope, some lines have no slope, and some lines have slope that's undefined. So I'm going to draw pictures here of all these different examples. Draw 4 graphs here. Just real generic graphs. Pick a different color for the lines here. So you get a line that looks like that, maybe another line that looks like that. Say a horizontal line, and then the last example is a vertical line. So, and the way I like to help have students remember this is to think about this in terms of driving on a road, and consider the line like the road that you're driving on. So if you're driving up this line, you're going up a hill, so this is going to be positive slope. As opposed to the next line, you're driving down the line, that's going to be negative slope. And then the second line, you know, these first two lines, there's some steepness there. You got going up a hill, down a hill, there's steepness, there's slope. But the third line, there is no steepness, it's a flat road. So that's going to have no slope. And then the last one, think about, what if you had a road that went straight down? Could you drive on a road like that? Definitely not. So, I mean, there's no roads like that. In that case, the slope's kind of crazy, so it's undefined slope. Okay, the last thing we're going to talk about this section is slope-intercept form. And so we're going to talk about one form of a linear equation, and that form is called slope-intercept form. And so if we have an equation with slope m and a y-intercept is the point, remember, has an x and a y, so the x is 0 and the y is b. This always has the form y equals mx plus b. And a lot of you have probably seen this before, so it might not be something new. And we'll just label these parts again. So this, again, m is the slope, and b, the point 0b, is the y-intercept. We already talked about intercepts. Remember, With a y-intercept, you always let x equal 0. So we know the x-coordinate is 0, but the y-coordinate is b. So very simply put, in this next example, notice it tells us the slope. That's what in the equation? That's the m. And then it tells us the b. It tells us that b is 3. Right? So if I want to find the equation of a line, I just can use the slope-intercept form. And so that's going to look like, just like we have up here, y equals m, but m is negative 2 over 5, negative 2/5. The x stays, plus b. b is 3. Notice this is a linear equation in 2 variables because it has an x and a y. So it's a pretty simple example, I think. So we have one more example in this section. It's a little bit tougher. It says find the slope and y-intercept of the line 6x minus 3y equals 9. Then graph the line using its slope and y-intercept. So if we go back and look at the last example, in this equation it's really easy to see what the slope and y-intercept is. We can just look at it and know this is the m, the negative 2/5, and this is the y-intercept is 3. But here it's not in that form. Notice here we solved the y. We needed that here. This is already got y by itself. Here we need to solve for y. It's a good thing we know how to solve equations. So I'm going to go ahead and rewrite that equation. I have 6x minus 3y equals 9. And notice I don't have y by itself. So if I want to get y by itself, the first thing it needs to move is the 6x. We got to move that to the other side. Remember, of course, our same old adage goes, change sides, change signs. So if we rewrite the equation with what we have negative 3y now, and I'm going to go ahead and write the negative 6x first, and then there's no sign in front of the 9, so we can assume it's a positive 9 or negative 9. Positive 9. The reason why I wrote the negative 6x first is because, remember our form, it's mx plus b, so we want the x part first. Also, note that we can't combine these terms. They're not like terms. This is an x term. This is just a number. Now, we still do not have y by itself. We have negative 3 married to y with multiplication. Of course, we know to undo that, we need to divide by negative 3. But if we divide by negative 3 on the left side, we also have to do it everywhere on the right side. So here we get a cancel. So the left-hand side becomes just y. And on the right-hand side, we have negative 3 divided, or negative 6 divided by negative 3, which turns out to be a positive 2. The x comes along for the ride. And then 9 divided by negative 3 is a negative 3. So we now have our equation in slope-intercept form. The slope is 2, and the y-intercept is the point 0. X is always 0. Y is negative 3. Now, how do we graph the line if we have that information? It's actually quite easy. So the first thing is we're given a point. We're given the y-intercept, 0, negative 3. So the point 0, negative 3 is down here, the y-intercept. 0, negative 3. You should get in the habit of always labeling your points. And then we have a slope of 2. Now, usually we think of the slope as a rise over run, but 2 is not it's not a fraction. So I can turn it into a fraction by putting it over what? Over 1. So this is, the rise is 2 and the run is 1. So to graph that, we're going to start at this first point and we're going to rise 2 and we're going to run 1 unit. We're going to rise 2 units, rise 2 units, and then run 1 unit. So once you've done that, then you can go ahead and draw a line through those points. You should also label that second point. That is the point 1 in the x direction and -1 in the y direction. And there you have it. That's the equation, or that's the graph of the line 6x minus 3y equals 9. First thing we do is we solve the equation for y, so it's in slope-intercept form. That allows us to find the slope and the y-intercept. You graph the y-intercept first, and then starting at that point you use the slope, and in this case the fact that we have a rise by 2 units, a run by 1 unit to find a second point. 2 points are all you need to graph a line. This method is much quicker than the method we talked about on the last video where we just found points. Okay, now that we've spent some time talking about slope and y-intercept, let's see how we can apply this to some real-world situations, because that's where things start to get a little bit more interesting. So we know when we have the form y equals mx plus b, there's 2 main parts there. We know the m is the slope, and we talked about finding it by taking the change in y's, or subtracting 2 y values over 2 x values. And the key thing to see here is this is a quantity divided by a quantity, which most of the time in the real world we think of this as a rate, or a rate of change. Examples of this could be things like miles per hour, could be dollars per minute. Lots of different rates out there, lots of different rates. Dollars per pound, many different rates. So when I see this equation, I see y equals 13x plus 77, we should be able to pull out that the slope, that m is 13, and this is a rate. And remember, it's a rate of the y over the x. Now, what is my y and x represented in this problem? Well, it tells us that y is the number of Americans in millions who have cell phones, and then it tells us something about x. It says the number of Americans y in millions who have cell phones can be approximated by the equation y equals 13x plus 77, where x is the number of years after 1999. So what we want to remember is that this slope, this 13, is a change in y over a change in x. So the units are y over x, which in this case is millions of Americans with cell phones, over x is the number of years after 99. So this is basically saying that we can expect the number of Americans with cell phones, number of Americans with cell phones will increase at a rate of 13 million, remember it's in millions, 13 million per year. It's a rate, see, something per something. This is millions of people per year. Okay, second thing, the y-intercept, the b. The b is like the initial amount, or the starting amount. Because remember, the y-intercept always happens when x is 0. It's always 0, comma, b, and in this case x is the years. X is the years, so years after 1999. So if I'm 0 years after 1999, that means it is the year 1999. So that number right there means that in 1999, so that's when this whole situation started. In 1999, 77 million Americans had cell phones. In 1999, 77 million Americans had cell phones, and then it increased at 13 million a year. So if you add 13 to 77, that means in 2000 there's 90 million, and so on. It keeps going. Let's look at one more. So this one says the number of nursing students enrolled in an accelerated baccalaureate program X years after 2004 can be approximated by the equation y equals 1200x plus 690. So the equation, this equation right here, tells the number of nursing students enrolled. And then X is the years after 2004. So if I'm talking about the slope, the m, of course in this case it's this 1200 here, that 1200, what does that mean? That means that that's the increase in enrollment per year. That means the nursing program's enrollment increases by 1,200 students per year. Remember, it's a rate of change, and in this case it's students per year. In most of these problems it's going to be per year. Part B, find the y-intercept. Well, the y-intercept is the point 0, 60, 90. Remember, 0 is the years, and this is the number of students. So 0 years after 2004, that means in what year were there 6,090 students? That means in 2004. In 2004, there were 6,090 students enrolled in the program. And finally, use this equation to predict the number of nursing students enrolled in an accelerated baccalaureate program in 2016. Well, 2016 is how many years after 2004? We can subtract to find that out. That's 12 years. And so if I want to find how many students there are, that means that x is, I want to find out how many they are when x equals 12. So I can just say y equals 1200x plus 6090, and I'm going to put in 12 for x, and then add it to the 6090, and we can do that with a calculator. So if we take 1200 times 12 and we add to that 6090, we get 20,490. 20,490 students. In what year? In 2016. So now let's go ahead and move to parallel and perpendicular lines. This is the second section on this video. The starts out with, how do we determine if two lines are parallel or perpendicular? And really all you need to do is look at the slope. Two lines are parallel. What do we know about parallel lines? So parallel lines are lines that don't intersect. What can we say about the slope of these two lines, or the steepness? Are they the same? Are they different? Well, hopefully you're thinking to yourself that the slopes are the same. They have the same steepness. If they're never going to cross each other, the slope should be the same. So we can say two lines are parallel if their slopes are equal. Now perpendicular is different. Perpendicular lines is two lines that cross at a 90-degree angle between them. So we use this little box to signify 90 degrees. So those would be two lines that are perpendicular. And one thing you'll notice about these two lines is one of the lines is always going to have a positive slope and one is going to have a negative slope. So the slopes are always going to be opposite signs. And it turns out that if two lines are perpendicular, if their slopes are negative reciprocals, meaning they have a different sign and the slopes are reciprocals of each other. So we'll talk about what reciprocal means here in a second. If I look at these first two lines, we should be able to tell what the slope is. Remember, the slope is the m that comes in front of the x. So in the first line, the slope is 3. In the second line, it's a negative 3. Are those slopes the same? Is 3 the same as negative 3? No, 3 is not equal to negative 3, so not parallel. Okay, let's go ahead and look at the next example. In this example, the two lines are not quite as convenient for telling if they're parallel because they're not solved for y, but we just got practice doing that. So let's go ahead and try this again. Remember, we want to move the x part to the other side. So because it's a 5x, if I move it to the other side, it becomes a negative 5x. And then for the other line, if we move the negative 10x to the other side, it becomes a positive 10x. So the first line we can rewrite as negative 3y. Remember, we're going to write the negative 5x first. We cannot combine it to the 6, and this is a positive 6. Okay. The second line, we have 6y equals positive 10x. I'm not going to write the positive here because it's at the front. And we have minus 42. We still don't have y by itself in the first line. That means we need to divide by everything by negative 3 to cancel those negative 3's. They divide out, which leaves us with y equals negative divided by a negative is a positive 5 over 3x, and 6 divided by negative 3 is negative 2. Moving to the next example, we have to divide everything by 6 here to get y by itself, which gives us y equals 10 over 6. Well, that does reduce to 5 over 3x, and 42 over 7, or 42 over 6 is 7. It's going to be a negative 7. So notice here, what can we say about the slopes? Are they equal? Yes, they are equal. Slopes are equal. These slopes are equal. So the lines are parallel. Simple enough? Okay, now how do we tell if two lines are perpendicular? Well, remember, we tell if they're perpendicular if their slopes are negative reciprocals. So, again, this is another example where we need to solve both equations for y. This is great practice doing this. In fact, why don't you go ahead and pause the video and try to do it on your own, and then you can check your answer here in a second when you come back. Okay, welcome back. You should have got these two lines when you did your work. If you didn't get these answers, go ahead and check your work to make sure you didn't miss a step somewhere. Notice the slopes of these two lines. The first one has a slope of -2. The second one has a slope of 1/2. Notice, first of all, the signs are opposite. They're negative of each other. If this is a negative, this is a positive. They're opposite reciprocals or negative reciprocals. And then notice they are reciprocals of each other as well. 2 over 1 is a reciprocal of 1/2. So they're different signs and they're reciprocals. This can be thought of as 2 over 1. Since this is the case, they are perpendicular. So just to review, if you want to check to see if lines are perpendicular or parallel, you just compare the slopes. We have one more here. Example. Are the given lines parallel, perpendicular, or neither? Well, look at the what? What do? We look at the slopes. Do we know the slope of the first example? Well, yeah, it's the number in front of the x. We know that m is -3 over 4. Do we know the slope yet of the second example? No. You gotta go ahead and solve for y. So move 12x to the other side. It becomes a -12x. Okay, when you do that, you get -9y equals -12x minus 15. We divide by -9. Do that. You get y equals, negative divided by negative is a positive, and 3 goes into 12 4 times, 3 goes into 9 3 times, so we have 4/3. And then negative divided by negative is a positive. Again, 3 goes into 15 5 times, and it goes into 9 3 times. So we get y equals 4/3 x plus 5/3. Look at the slopes. We have -3/4. In the second one we have 4/3. Are the signs opposite? Negative, positive, yes. Are they reciprocals? 3 over 4, 4 over 3. Yes. So the answer is that the lines are perpendicular. Alright, one more set of examples here. We want to find the slope of the line that is parallel to y equals 2/5 x plus 2. If the two lines are parallel, their slopes are the same. So the slope of a line that is parallel to this line should have the same slope. So the slope should be 2/5, the same as the slope in this line. Now if it's perpendicular to this line, the slope should not be the same. The slope of a line perpendicular to this line should be the opposite sign, so it's a negative in this case, and also the reciprocal, 5 over 2. Okay, that does it for this video. Thank you for your time. See you in class.